In this section, we'll talk about how to do a successful proof of concept or evaluation. For some strange reason, customers don't seem to believe us that we can reduce their traffic on their WAN by on average 60% and accelerate applications in the 5 to 50x range. So they're going to want to see how steelheads work in their environment. Some customers will want to see the steelheads work in their lab. Some will want to see them work on their production network, and some will want to do both. Pretty typical is customer will bring us into a lab, make sure we don't break anything terribly, and then put us into production for some period of time. It may be just the steelheads they're looking at, or most often it's against some competitor. We have a test plan available. It's out on the partner site. You can download it. So it's a very good document that will give them ideas on what to test and how to test, and basically highlight what our strengths are. In general, the more different applications that you're trying to test and the more sites tested, the better we will look. Our competitors have many weaknesses, and the two biggest ones are scalability and the lack of application-specific optimizations. So that's why we say try as many applications as you can. If you go into a test against one of our competitors and it's strictly a CIFS drag and drop test, and that's all they're going to test, it's going to be very hard to justify the steelheads, because we're going to be probably more expensive depending on the competitor, and the results will be similar if in just CIFS. So you need to make sure you test CIFS and MAPI and FTP and SQL if you can, SSL, HTTP, all these different applications, and that's where we're going to look the best. And then of course the more sites you can test, the better, because all of our competitors have scalability issues. It's important to get an idea of why the customer is calling you. What is it that they're trying to achieve? What is the business case? Because if they can't answer these questions, they may just be a tire kicker, and we get that sometimes. We get customers who take the product in, test it, see the benefits, love the product, and then return the product and say, well, we don't have budget at this point in time. So to try and get rid of those kind of tire kickers, it's better to figure out what it is they're trying to do and what is their pain. So is it a bandwidth issue? Is it a latency issue? Or is it backup or replication? Is it a consolidation play? If you can figure all that stuff out up front, it will make things go smoother in the end. So remember that our sweet spot is focused around the WAN, so the slower the links, the higher the latency, the better we will look. Customers are probably going to want to do a calculation to see what the return on investment, or ROI, is of the solution to help justify the cost to management. So out on the website, the partner website, we have an ROI calculator. It's basically a spreadsheet where you can plug in numbers about the customer's networks and then the cost of the steelhead solution, and we can give you a return on investment projected amount of time. So here's some customers and some of their thoughts on the ROI calculation. Greenhill Investments saw a 4-month payback period. They were able to take Exchange servers and pull them back into the data center. Gensler Architecture, one of the biggest architecture firms in the nation, saw a 1-month payback period as they were able to collaborate across the country and around the world. LG Electronics was able to reduce and get rid of some of their WAN pipes, and it was easy to calculate a 5-month return on investment for them. And finally, Little Diversified saw a 6-month payback period when they saw backups go from 4 hours down to 5 minutes. In general, you will see most customers find a 6-month or less payback when using our solution. As we talked about briefly before, if there's competitors involved in the testing, make sure that you use our test plan that's available for download out on the partner site. The test plan will not only prompt the customer on which applications to test, but also tell them and show them how to test those applications so they can see the best results. There's a few things that really make us stand out, and the first one is with email attachments. If you know the way MAPI works for exchange mail, if you attach a file to an email and send it off, MAPI will actually encode the file in such a way that it doesn't look like the original file anymore. The steelheads are smart enough to know this and will actually unencode the file and send it across in its entirety so that we're therefore warming up the data stores. So a great test for us against any of our competitors would be, attach a file to an email, send it through the steelheads, and then do a CIFS drag and drop, NFS, FTP, some other transfer of that same file back, and you will see that you've got warm performance, where all of our competitors will end up with cold performance in that case. HTTP and HTTPS are also great things to test. You can test printing and show how much reduction we will give you there. And then for QoS, things like Citrix, RDP that we don't help directly, you can make sure that we handle it correctly with our QoS engine. For any proof of concept or evaluation, there's basically 3 steps. There's preparation, there's installation, and then there's the post-installation. And we'll go over each of these in detail over the next few slides. So for preparation, the first thing you need to do is obtain a network diagram. The network diagram will give you a good picture of what's happening in the current network and also point you at where the steelhead and how the steelhead should be installed. Next, for staging, there's a couple of things you might think about. First of all, it's not a bad idea to do a show run and copy and paste the output of that into a text file. In the configuration file that you get in the show run, you'll see the licenses, and if you lose the licenses for any reason, it'll save you a support call. If the equipment that you're installing is your equipment, then you're going to want to make sure you do a reset factory. That will get rid of the old configuration and get rid of any parameters that may be left in the configuration. If the steelhead comes straight from Riverbed, then it will already have been wiped out and be ready to go. The other thing to think about is stability of the software versus new feature. In general, you want to use the latest version of software that has the features that you need. So right now there's 3.0 software, there's 4.0 software, there's 4.1 software, and there's 5.0 software. So in general, each one of those new versions is going to have new features. So you want to go with whatever features you need. Try and stay away from brand new code. So if a code version has only been shipping for 1 month or 2 months, then you want to try and stay away from that if you can. If you're using SSL or testing SSL, you need to make sure you have the SSL license. The SSL license is free, but it does not come on the box automatically. It's for export restrictions. So you have to go to a website, put in the serial number, and then you will get the SSL license that you can copy and paste into the steelhead. If you can pre-configure the steelhead for the customer's network. Many customers won't want you to do this because they've heard that the steelheads are very easy to deploy, and so they want to see for themselves. So maybe instead of pre-configuring them, you set up a time to go to the customer site and help them configure the product. And then line up all the components you're going to need for your final report. So first of all, you're going to want to do baselines. So you're going to want to time some applications that are important to them with a stopwatch or with some kind of a tool if it's available. And then make sure you get graphs before the steelhead goes in as far as the wide area network and what the utilization is on the wide area network, so you can show them afterwards how much data we're taking off of the WAN. Steelhead appliances are extremely easy to configure in a basic in-path installation. If you're doing WCCP or policy-based routing, then you need to gather some information and have a Riverbed resource, either the local SE or support department, help you. For an in-path deployment, the bare minimum configuration is an in-path interface IP address, in-path interface default gateway, and then matching LAN and WAN interface speeds, hopefully full duplex. The biggest issue we have with trials and proof of concepts is duplex mismatches. I know it's easy and I know everybody checks, but for whatever reason they seem to get missed in a steelhead installation, and you will never see the throughput that you should see if there's duplex mismatches. What we'd rather have than just this bare minimum is an in-path IP address as before and a default gateway plus primary interface in IP address and default gateway. So the primary is used for managing the steelhead appliance if the in-path interface goes away. You should also configure some static routing if there's a layer 3 device on the LAN side of the steelhead. So if it's a layer 2 device on the LAN side, a default gateway pointed at the WAN is good enough. If there's a layer 3 device with some VLANs behind it, you need to either do some static routing or turn on simplified routing. Simplified routing just does a learns MAC address to IP address mappings and keeps a table. And then you should configure the correct date and time so that the reporting and the log messages actually mean something if you do have to do some troubleshooting. So again, the installation of the steelhead appliance is really quite easy, but there's a couple of things that you should think about. First of all is the correct cables. And I know this sounds easy, but it's something that does get missed and screwed up time and time again, so that's why we have to talk about it. We look like an end station type device, so that means you're going to use a straight through cable to a LAN switch, and you're going to use a crossover cable to pretty much anything else, a firewall, a router, another steelhead if you're doing a serial cluster. So just make sure that you have those cables in place, because what you can end up with is that it works fine when the steelhead is optimizing traffic, but when we fail to wire, you lose link and traffic stops flowing. So obviously that's not what you want to happen. So test your fail to wire feature after you get the cabling correct. What I like to do is install the steelhead powered off, and if the steelhead works correctly and passes traffic when you're powered off, then the cabling is probably correct. Turn the steelhead on now and then check your interface statistics for errors. You're going to see duplex errors show up as CRC errors and other kinds of errors in the interface statistics screen in the steelhead. Then I always like to take a look at the current connections graph and make sure that we have connections being optimized. That'll tell you for sure that the steelhead is seeing another steelhead in the network and that some optimization is occurring. Next, perform an end-to-end drag and drop. For example, since CIFS is our best case performance in the steelhead, map a drive across the network and just copy a file that's a 2 or 3 meg file, and what you're going to see is that if it took 20 seconds or 50 seconds, a minute before, you should see that transfer once we've seen it. So if you copy the same file again on a warm transfer, you should see that go down to 2 or 3 seconds. And if you don't see that, then there's something wrong, and it could be a duplex problem right next to the steelhead, or it could be a duplex problem down the line from the steelhead, either from the server to the switch or maybe between switches. The idea is you got to get a good feeling that end-to-end acceleration is performing as expected, because you never want to have the customer do a bunch of testing, call you back and say, you know what, we just spent 2 days working on this thing and I just don't see much difference. It's not much faster than without it. That'll tell you right away that something's wrong, and if you go back in and you find something easy and you fix it, now the customer's going to be mad at you because they wasted time testing when the box wasn't configured properly. So never leave until you're absolutely sure that the boxes are performing as advertised. So whether you install the appliances for the customer or whether the customer installs the appliances themselves, you should always verify the installation and make sure that it's correct. So again, I know we've already talked about this, but it's just the number one issue. We run into it in almost every customer we talk to. And so What happens sometimes is the steelhead will be set up for auto and the switch or router will be set up for full duplex, and this will never work. You're always going to end up with a duplex mismatch in this case, because the way auto negotiation works is if the auto negotiation device, in this case the steelhead, cannot talk to the other side, cannot auto negotiate at all, then it's going to drop to half duplex by default. And so if you then you're going to end up with a duplex mismatch. Absolutely. So what you really want to make sure is that you have auto on both sides, or you want to have full duplex on both sides. Another thing you need to think about is to make sure that the speed and duplex is the same on both sides of the steelhead appliance. So here's the issue: is if, let's say, the switch supports gigabit speeds, so you hard code it at gigabit speeds, and the LAN side of the steelhead at gigabit speeds. But the router only supports 100 megabit connections, so you hard code it at 100 meg and the WAN side of the steelhead at 100 meg to match. So now you don't have any duplex mismatches, and as long as the steelhead is up and optimizing traffic, everything's fine. But as soon as we fail to wire, now you've got a hard-coded device at a gig trying to talk to a hard-coded device at 100 megabits, and that'll never work. You're going to end up blocking traffic, which is obviously not what you want to do. So you need to make them the same on both sides. So in this case, we've got 100 full duplex on both sides of the steelhead. The other thing you could do instead of that is hard code both sides at all the way through at auto. So you make the switch, the router, and the steelhead all at auto. This is a great scenario too, but you just need to make sure, check all the devices and make sure there's no duplex mismatches, because auto negotiation doesn't work reliably 100% of the time. As I said before, if you're doing a logical in-path design using WCCP or policy-based routing, you need to gather some information and let us know this information. So first of all, what you need to do is check the Cisco router or switch model and the iOS version that's running. We need to know the peak CPU of the router. We need to know if there's an extra port on the router that we can hang the steelhead off of. We need to check CCO, Cisco Connection Online, to see if there's any WCCP bugs for that iOS version. And you can do that yourself, or you can just forward that to us, either the support guys or your local Riverbed SE. And then we need to know which subnets are involved in the redirection. So which subnets do we need to catch and redirect to the steelhead? That'll help us figure out what the access list should look like for this. After the installation in the customer's environment, there's a few things you can do to find potential problems. The first thing is to check the traffic summary for pass-through traffic and to see if it seems correct that we're passing that traffic through. A lot of times customers will put a steelhead into their data center, and then they'll put, let's say, 1 or 2 steelheads out at remote sites. Let's say they have 50 remote sites, but they only have steelheads at 2 of those remote sites. So when they look at the reports in the data center steelhead, they're going to see a bunch of pass-through traffic, and they're going to say, hey, this box isn't doing what it's supposed to. Well, it's probably pass-through traffic that's going to sites without steelheads, but you do need to verify that. If it is traffic going to a site with steelheads and it's not being optimized, then we need to dig into that and figure out what the problem is. And one of the problems it could be is asymmetric routes. So if the customer has more than one way in and out of their network and the steelhead is only sitting on one of those links, then traffic could go out through the steelhead, come back through the other link, bypassing the steelhead. And in that case, we won't optimize those sessions. So you need to understand that and look for that. And I've seen plenty of customers who swear up and down that say, no, we only have one way in and out of our network, and we find asymmetric routes and find out they do have a different pipe going in and out. So it's something that's worth looking at. Under advanced networking asymmetric routes, you can see a list of devices by IP address that we think are talking to each other, that we see as having done some asymmetric path. So it's worth checking there to see. And then finally, TCP dump. Since this is a Linux appliance, it does support TCP dump, and we can actually capture packets. And so if you're working with support, they will ask you sometimes to do a TCP dump, especially if it's an application issue, and take those files and forward them to support for troubleshooting. If you're familiar with Wireshark and TCP dump, you can certainly take your own traces and do troubleshooting yourself. After the test is completed, it's important to put together a final report that proves that the steelheads did their job. So that's why it's important to understand the customer pain point up front. Is it WAN network congestion? Is it user experience? Or is it both? So if the customer wanted to reduce the WAN bandwidth on their network so that they could maybe shrink the size of the pipe they currently have or not have to upgrade the size of their WAN link, then you need to make sure you have graphs from before and graphs from after that show once the steelheads went in, the bandwidth was reduced by 80%. The other thing is, if it was user experience improvement, then you need to have timings. So usually it's high-tech, like stopwatches. So you're sitting there and you time a transaction before, you time it with the steelheads in place the first time, a cold transfer, and then you time it again a second time to show the warm transfer rate. And a lot of people will put together a spreadsheet that shows the different timings and how they all worked out. If this is going to upper management, then it's probably important to not only show the raw data, but also verbalize it in a way that's easy for them to understand.